Uh, Good afternoon, everyone. Welcome to the last session of the day. We have an incredible panel lined up for this session, which is on smart manufacturing and operational performance. This session will focus on some wonderful and informative presentations from Mr. Arun Gopalaswamy, Factory Manager, ITC and ICML, and Mr. Ramesh Dham, Lead for Digital Transformation Initiatives at Coromandel International. Yeah. So before I hand the stage over to our esteemed speakers, I would like to take the next few minutes to introduce you all to a topic that is fundamentally reshaping the industrial landscape, that is autonomous operations. The insights that I'll be sharing today were initially developed by my colleague based out of Boston, Mr. Mark Sengupta. He is the Director of Research, and I'm using this opportunity to share it with all of you. Uh, So most industrial plants today are automated using sensors, alarms, control systems, predefined logic to run efficiently. Uh, but automation and autonomy are different. Automation performs programmed tasks while autonomy can sense what is happening, assess the situation, decide the right response, and act with limited human intervention. In this presentation, I'll walk you through the stages of automation operations, then look at some real-world application examples, discuss the benefits, and then end my presentation with a brief explanation on the autonomous operations technology and process stack. So now we are going to have a quick overview of the autonomous operations levels of maturity. Uh, it is critical to understand that a facility or plant does not become fully autonomous from automation technology, which is abbreviated over here as AT, overnight. So it is a maturity journey. Think of it as a 5-step ladder. With each step, the system gains more ability to act, moving humans away from the constant manual control and move towards more strategic oversight. Now let us go through a detailed explanation of each of these levels. So we begin with the first level, which is operational assistance. At this level, the system is not really acting on its own. Its main job is to help people understand what is happening in the operation. It may show data, alarms, trends, equipment, conditions, and other useful information, but human operators still make the final decisions and take most of the actions. The second level is basic automation, which is the place where the system can actually handle simple routine control on its own. For example, it can keep temperature, pressure, flow, or level within the right range by adjusting a valve, pump, damper, or a motor. Now, people are still in charge, but the automation helps them keep the process stable and reduces the need for constant manual adjustments. Now we move on to the third level, which is advanced automation, where the system can recognize some common problems and act on them. It is no longer just doing routine control, it can make simple decisions based on what it sees. Now, for example, it can reject an underfilled bottle or stop a batch when conditions look abnormal. So, however, people still need to be available for unexpected issues that the automation cannot handle on its own. The fourth level is select autonomy, which introduces the first true autonomous operation but in a very limited form. This means that the system can take care of certain problems by itself. However, if something goes wrong, like a pump showing signs of failure, the system can act immediately by moving the operation to a secondary pump. It will also notify the team, but humans are still needed to investigate the issue, fix or replace the failed equipment, and return the process to its normal autonomous mode. The final level that we want to discuss is full autonomy, which is the highest stage of autonomous operations. The system can run the operation by itself and it can understand what is happening, decide what needs to be done, and act without waiting on a human operator. A good example can be an autonomous mine where trucks can haul without the drivers. These trucks can move material, they can detect obstacles, they can avoid the collisions and continue working safely. People can still monitor the overall operation, but they no longer required for the day-to-day control or immediate intervention. Now, full autonomy is the long-term vision, but companies are already proving its value today. So, to make this concept more practical, let us look at some real-world examples. The first example that we are going to talk about is of JSR Corporation. The problem here states that it needed to control a complex chemical production process while maintaining product quality and using the waste heat efficiently. What the solution was implemented was the reinforcement learning AI that could safely manage the plant beyond traditional control methods. The results achieved were 35 days of stable autonomous operation, 40% lower steam use, reduced costs, safer operations, and better productivity. The next example that we are going to look at is Ineos Corporation, which the problem here was they had to manage a complex crude oil processing unit where skilled operators traditionally controlled many variables. The solution was an AI system that monitored key operating factors and adjusted the valves in real time. So the key benefits included improved process stability and efficiency, reduced dependence on human expertise, scalability, safer refinery options, and sustainability contribution. Third example is of Sanofi, where traditional manufacturing facilities were not flexible enough to quickly adapt to changing production needs. So the solution was a modular manufacturing concept which was supported by digital intelligence, automation, and human expertise. Key benefits were improved flexibility and speed, increased efficiency, enhanced quality, reliability, and sustainability in biopharma production. Now, these examples show that autonomous operations are not just a futuristic idea, they are already being tested and applied in complex industrial environments. Now, let us talk about the benefits. So, why are autonomous operations so valuable? The autonomous operations can help people run plants more safely, consistently, and efficiently. They reduce manual effort, avoid repeated human errors, and keep operations aligned with standard procedures. The result is a better productivity, more reliable equipment, steadier product quality, improved safety, and more sustainable performance. Now, autonomy does not remove the role of people, it elevates their role. Instead of manually adjusting valves, operators move into higher value roles like exception handling, process optimization, and strategic oversight. So, industrial expertise is not getting replaced, rather, it is getting embedded into the system. Now we discussed about the maturity levels, real world use cases, and the benefits of autonomous operations. I will end the presentation with an overview of the autonomous operations, technology, and process stack. So the technology and process stacks gives you a holistic overview of the requirements to achieve a reliable, efficient, and successful autonomous operation. Autonomous operations should be seen as a crawl, walk, and run journey. You cannot jump directly into an AI-driven autonomy without building the right foundations first. So at the crawl stage, the focus is on getting the basics right. Reliable instruments, good data, stable control systems, and sound base logic configurations. Without these basics, autonomy will not be safe or dependable. Now, at the walk stage, the organization builds the supporting pillars. This includes skilled plant staff, maintenance teams with automation knowledge, strong automation expertise, standard logic practices, and reliable network support. These pillars help make the automation sustainable and scalable. Now, in this stage, you can witness that something called AI is here. AI isn't running the plant yet. It acts as an intelligent co-pilot. It predicts equipment failures for maintenance, guides operators in real time, optimizes automation logic, and monitors network security. So the main takeaway here is that AI is simply empowering people to build reliability and consistency. Only after the foundation and the pillars are strong can the operation move to the run stage. This is where the real-time optimization, manufacturing operations management, systems and autonomous operations can create value. In the run stage, AI transitions from a supportive assistant to an autonomous engine. By independently optimizing processes, preventing breakdowns, and linking plant data to enterprise goals, AI takes over routine execution. So the result is a proactive, highly efficient plant where machines drive the operations and humans supervise the outcomes. A moral of this slide is AI may sit at the top, but it only works when the structure below is strong and reliable. And that brings us to the core agenda of the session today.